Hello. My name is Marcia Moore, and I would like to welcome all of you to this, the first lecture in our Fall Museum Without Walls lecture series. This is the 18th year of the MWOW series, and the Gateway Science Museum is completing our 10th year of actually having a museum with walls. Although, as I'm sure you realize by being here virtually because of COVID-19, we truly are a museum without walls. Before proceeding to tonight's presentation, I want to acknowledge the great help of our MWOW committee, our Executive Director, Adrian McGraw, Exhibits Curator, Stephanie Parker, and Gateway Science Museum Community Board member, Dr. Rachel Teasdale. We also owe profound thanks to all of our series lecturers who are going above and beyond to present topics of immediate and long-term interest and benefit in the realm of science for our community. We also thank our series sponsors, NSPR radio station, Renee and John McCamus, and Marcia Moore. And in a very special honoring of those who preceded us, we acknowledge and are mindful that CSU Chico stands on lands that were originally occupied by the first people of this area, the Mechoopda, and we recognize their distinctive spiritual relationship with this land and the waters that run through campus. We are humbled that our campus resides upon sacred lands that once sustained the Mechoopda people for centuries. Tonight's lecture will be on one of the most important topics of our time, climate change, and an important related topic, the denial of science. Our speaker is Dr. Michael Abruzzo, Professor Emeritus at CSU Chico, and former chair of the Department of Biological Sciences here, where his specialty was molecular cytogenetics. Since his retirement, Dr. Abruzzo has worked to promote public understanding of science with a central theme that humans are a part of the environment, not apart from it. We are presenting a recording of an invited lecture he gave for Chico State's Department of Biological Sciences last February. And we are honored to have him with us during this Zoom meeting, and he will be available to answer your questions after you have viewed the video.
Well, Stone Agers in the fast lane needs a little bit of explanation. Flowing down the river denial, that's probably pretty clear. So, genes, you know I'm going to have to mention genes in this talk. Genes are one replicating system on the planet. Gene frequency can change through time, evolve. In humans, the rate of change is slow. So the humans are the Stone Agers. The rate of change is kind of slow, but it exists. It's your standard biological evolution. Now, culture and environment also change and evolve through time. But the rate of change is much more rapid than the rate of change in the genes. So that's a bit of a dilemma, because you need to be able to adapt to your environment for survival. Now, if the environment is changing much more rapidly than your genes, you're going to have to use some other system to be able to survive. And why are you worried about survival? What's extinction? You've heard of that. 99%, more than 99% of all species ever existed on the planet are extinct. So it's kind of like a rule in evolution that you're trying to outwit. And how do you do that? Humans are capable of adapting to rapid change because of their nervous systems, their brains. If you use your brains, you can keep up with the changes in the environment through adaptation using a gene-produced structure, organ, your brain. But sometimes we don't use information. We deny the existence of information, and the denial of that information causes real problems, because now we're not making evidence-based decisions, and that could affect our survival. So basically, that's the talk, okay? So, selected history of the denial of science, okay? We'll go a little further. Impacts of denial of evolution. About a third of the US population does not believe in evolution. Okay? It's a pretty high number. They do not recognize that all life is related, even human life. Now that causes a bit of a problem in terms of your perception on the planet, because it's important that you have a perception that you are a part of the environment, not apart from it. And as soon as you remove yourself from it, you have a very biased view of it. And an extension of that is you really need to understand that you're the product of evolution, not the purpose of evolution. So if you have an evolutionary idea in your head, if you live in biology, you use that information to help you make decisions. But if you don't, the information you're using is biased information, and it may not work for you. Now, also, the modern-day life sciences are all based on evolutionary foundation. We can't go into great detail of why, but it should be pretty clear to you it is. And if you deny medical information, maybe you're an anti-vaccination person. What's that lead to? Childhood diseases, cervical cancer in young women, just to mention a few. Okay? So there are real impacts from not utilizing your brain to make decisions that are important for your survival. Here's a big one, denialism of tobacco and cancer. For most of you, you say, what's that all about? You know that cancer, I mean, if you smoke cigarettes, you get cancer. You're not denying that, you know that. Well, go back to 1912, lung cancer was a very rare type of cancer. Read the medical textbooks. It's not present. It's very rare. After World War II soldiers get ready access to cigarettes, epidemiologists note probable relationship between cigarette smoking and lung cancer by the 1930s. So something that was rare is now occurring more frequently. What else was going on? Cigarettes were becoming popular in culture. A few years later, then females took up smoking, and then you saw the lung cancer in females following that. By the 1950s, it was pretty clear there was a dose-related effect. So you had a beautiful experiment here in humans set up by human behavior. You had a whoops, I knew I was going to do that. Okay. Set up by treatment group, the people who smoke. You even get the dose because people smoke different amounts of cigarettes. So you have a nice dose relationship in your experiment, very, very nice clean treatment group, a very good control group, all those who don't smoke and never did smoke. So they're out there, they're frequent. It's a perfect experiment to collect the information. Hence, they got the information and they got it pretty rapidly by the 50s. Denialism. Tobacco companies hire PR firms to begin a massive campaign to challenge the evidence. Nobody wants to do something that's going to give them cancer, so let's kind of remove that thought from their brains, and they'll buy our products. 1964, the Surgeon General says, nope, we're going to put warning on packages of cigarettes. Again, in that same year, industry says no direct link between cigarette smoking and disease. How can they say that? Well, you yourself personally get lung cancer. How do you know that it was from the cigarettes that you smoked, not from something else in your life? The direct evidence is very difficult because this, although it's a pretty good controlled experiment, it's not completely controlled because it's the human being involved. All right? So they can go on with that line for a long time, making people who smoke feel better about themselves, which is what they wanted to do. I was a smoker. I understand this. 1998, a number of years later, the denialism and the tobacco industry lost huge settlements, multi-million-dollar settlements. States got plenty of money from these settlements to improve their health system and provide money to pay for all of the individuals who had diseases related to smoking. Also, they got plenty of money to have advertising campaigns. So now the state could get into information dissemination, not just the tobacco industries. And you all probably grew up seeing those commercials that said how terrible it is to smoke. Paid for by the tobacco industry. Now, that's a good settlement. Philip Morris reports in the year 2000. Philip Morris was a tobacco company, in case you didn't know that. Okay? Overwhelming medical and scientific consensus for link between tobacco use and cancer. Overwhelming, sure. 7 million deaths occurred during that period of time from the 1920s until year 2000. Deaths due to lung cancer now, about 156,000 per year in the United States alone. But the rate of smoking dropped from 40% to 20%. So there are all kinds of regulations about where you can smoke. So you now have a relatively clean environment with respect to smoking. Okay? Let's move on to global warming, because there's some denialism here too. And this is the bulk of the talk. We're going to talk about the history, evidence, sources, impacts, and solutions. History. Between 1859 and 1900, it had already been determined that CO2 absorbed heat and the burning of fossil fuels could result in higher global temperatures in a century or two. That was the level of understanding about 1900, all right? The Industrial Revolution started in about 1850, about that same time. Guy Stewart Callendar observed temperature increases sooner than expected, already in 1939. It didn't take a century or two. Bit of a warning signal coming. In 1957, Roger Revelle and Hans Suisse, two Scripps oceanographic climatologists, say humans are now carrying out a large-scale geophysical experiment. That experiment was humans are releasing carbon dioxide into the atmosphere through the burning of fossil fuels, and now we're going to find out what's going to happen. That's the experiment, okay? Since I brought up treatment control once before, let's do it again. What's the treatment? Exposure to CO2, right? And who's in the group? Everyone. There's no control. We're all exposed to the CO2 in the atmosphere that's increasing, so we can't say, well, we're better than they're better, or that, oh, they have it worse than we have it. Not in terms of the CO2 in your atmosphere, maybe from some impacts from it, but not in terms of the CO2 you're being exposed to in the atmosphere. And we'll probably make a reasonable case that you're not free from the impacts to it either, okay? So this is a problem. We're all the victims, and we're all the perpetrators. This is not a good experiment. In 1957, the Scripps Institution, and that was Roger Revelle, also he was from the Scripps Institution, installed CO2 measuring device on Mauna Loa. Mauna Loa is one of the larger mountains on the island of Hawaii. Okay? Pretty nice clean air, not much surrounding it, a great place to put a device measuring atmospheric gases. So he decided it's about time we get some decent evidence on the amount of CO2 and had that put in. And Charles Keeling collected it. Here's the famous Keeling curve. I'm sure you've probably all seen it or heard about it. That's a beautiful curve. I mean, you couldn't ask for better data than that. You'd almost have to think that, oh, I probably fudged it, you know? That is just beautiful. Look at that increase. Just exactly what was predicted. There it is. That's from the time they put it in until now, when it's 415 parts per million. Then it was right around 300, okay? Started out about 280 way back here in the beginning of the Industrial Revolution. History still is going on. 1968, there's a geophysicist named Gordon MacDonald. He was a member of the Jasons. The Jasons were an elite group of scientists who provided the government, the presidents, the Pentagon, with information on national security issues. The government would say, what do you know about this? What should we do about it? How important is it? And they have advised lots of presidents, and the CIA frequently, and the FBI. Gordon MacDonald is talking to President Johnson at that time about weapons of mass destruction. And so he knew that when you drop a nuclear bomb, it will annihilate the target area. And that's good. You can actually have a target area. But at the point of release, then there's this radiation release. That doesn't stay at the target area. It gets into the atmosphere and flows through it and follows the weather patterns around the globe. You can't control where it goes. That's a major problem with nuclear war. Okay? Hence, we haven't had a nuclear war because we have mutually assured destruction. And that seems to have stopped nuclear war because you can't control the dissipation. But at that same time, Gordon MacDonald says, you know, there might be something worse than that. There's CO2 increasing in the atmosphere, and he advises the president that you can't control where this goes. And it's going to cause ecological damage, societal damage, geopolitical problems all around the world. You wanted us to advise you on national security. The increasing CO2 in the atmosphere is much more important than what you have under control with mutually assured destruction. So get on board with that. This is 1968, okay? 1971, the Jasons decided to work for peace instead of war. They focus on global warming. And in 1978, they predict what would happen under twofold increase in CO2. Temperature increases of 2 to 3 degrees centigrade. Dust bowl conditions around the world, American Southwest. Reduced access to drinking water because of dust bowl conditions, increased drought, etc. Decreased agricultural production, again, cascade effect. Rapid melting of the ice at the poles. All right, 1978. Where are we now? This is 2020. It's not very different. Look what they were able to predict in 1978. And it seems like we're still talking about it. They distributed this to the National Academy of Sciences, Environmental Protection Agency, NASA, National Security Council, White House, energy industry, Pentagon, just about everybody they thought should know about this. 1979, Gordon MacDonald teams up with Rafe Pomerantz. Now, Rafe is a lobbyist for Friends of the Earth. He's concerned about the planet Earth. Gordon MacDonald's worried about global warming. MacDonald can open the doors. The lobbyist knows what to do when he gets inside the doors. So they were a good team. And they went around and gave talks to anyone who would listen. They got the White House science advisors to listen. President Carter then asked the National Academy of Sciences to do a full assessment of the CO2 problem, 1979. President Carter also put solar panels on the White House. 1980, NAS begins this study. 1980, Ronald Reagan elected. He ran on a platform of deregulation of energy and the environment. He took the solar panels off the White House. 1981, 7 NASA scientists presented a paper in Science, the journal Science, one of our favorite journals, one of the best we have, showing an increase in global temperature. The lead author was James Hansen, a big player in climate change. 1982, Al Gore is a very young congressman. You may not know, Al Gore was a vice president of this country at one time, okay? He's a very young congressman. He took classes from Roger Revelle at Harvard and became very interested in global warming. So he decides to hold congressional hearings. He asked James Hansen to come. So they're starting to talk about global warming in 1982. Very good. 1982, Exxon is committed to a future of renewable energy. This isn't a typo. Okay? Very committed to a future of renewable energy because they're in the energy business. And you want to position yourself for the energy of the future. And they saw the handwriting on the wall, and they were committed. So they weren't fighting this. National Academy of Sciences finally announces their findings. There was a written report and then press interviews from the chair of the committee, and they differed. The committee report said, we don't have all of the data yet. We can't, it takes a while to collect all of these data because this is a human experiment and it takes time. We have to follow the progress. But what we see suggests we should take action now to reduce the burning of fossil fuels so we can reduce the greenhouse gases in the atmosphere. The committee chair goes around, is being interviewed, and the committee chair says, we do not have all of the data yet. There's no reason to get all that concerned at this point in time. We should just continue to collect information, and we'll come back to you with suggestions in the future. So there was a difference in the interpretation of this. And that changed the view of a number of individuals and politicians. So the government didn't get behind doing something right then. And the energy company said, well, if the government's not going to get behind it, why should we get behind it? So things changed at that point. So don't be blaming the energy industry right away, because the scientists presented their results in two different ways. In 1988, Hansen testifies, James Hansen again, that the greenhouse effect is here. It's now clear, it's here. George Bush Sr. is elected. 89, the Intergovernmental Panel on Climate Change is formed by the United Nations and the World Meteorological Organization to conduct scientific assessments and develop global policy. So things are moving forward, even though they're moving forward to collect more data, get more information to decide what needs to be done. Okay? James Baker, who's the Secretary of State under Bush, says it's time to develop a plan to deal with global warming. So get a plan, maybe take some action. But John Sununu, who was the chief of staff for Bush, tells Baker, stop talking about this. It isn't a good point to bring up. It frightens people, and the fossil fuel industry is very important to us. So all of the discussions that went on and looked positive at the end of the 80s kind of stopped. Okay? Now, people still move forward naturally. The fossil fuel industry they move forward with a big disinformation campaign. And they followed the model of the tobacco industry. And this is why I presented the tobacco industry as good models there. 1992, the United Nations gets involved, and they have their Framework Convention on Climate Change. It's the first near universal agreement to tackle global warming, agreed to reduce greenhouse gas emissions. So they have an agreement to reduce them again. No action, no plan, just an agreement. But that's someplace. 1995, the first convention of the parties, in case you ever wondered what COP means. Convention of the parties was held, one each year since. So a lot of talking since. And, whoops, there we go. COP21 produced the Paris Accord. So a summary of the history at that point. All the information we needed to take action was available by 1995. And many would say it was available by beginning of the 1980s. Okay? We knew what needed to be done and the advantages of doing it sooner rather than later. Unfortunately, denialism continued to impede action. The action was, let's keep talking about it. There wasn't any action, let's reduce it. All right? So now let's look at evidence. Pretty clear, there's your CO2. From the Industrial Revolution to today, 415 parts per million. Nice clear data here because that's Mauna Loa. All right? Those are the years once we put that in. Here are the greenhouse gases, CO2 mostly, and then methane, nitric oxide, and the fluorinated gases. Those are the greenhouse gases. They absorb heat, and in absorbing heat, hold it in, and increase the temperature of the planet. The more we put in there, the more that it'll absorb, the higher the temperature will go. It's pretty straightforward, very easy science, okay? Who does it? The major industrial countries, the major industrial countries. China, the largest producer of greenhouse gas emissions. But they weren't the largest producer until about 2004. The United States was the largest producer until about 2004, then China shot by, okay? And the United States, Europe, the EU, India, these are just major industrial countries. So they're the ones putting the CO2 in. Who does it per capita? Now, here we go. We're number one now, okay? Per capita, number one of the major industrial countries. There are some smaller countries that are in the Middle East that have oil and they need to really keep themselves air conditioned all the time, and they have a larger per capita. But it's nothing compared to the amount we put out, all right? So in terms of the major industrial countries in the world, per capita, we're number one. And also, just look at the others. The European Union, Japan, they're less than half. The European Union is less than half what we do. And they have a pretty good standard of living in Europe. Any of you have ever traveled there or seen television, you know it's pretty decent standard of living there, okay? More evidence. Is the planet warming? Yep. Pretty clear. Let's go right over here. Let's put 2019 in right there. So the last 5 years are the 5 warmest years in recorded history. You're scientists, that's not a random event. The last 5 years are the 5 warmest years in recorded history. And if you look at the last 20 years, 19 of them are the warmest in recorded history prior to the ones that came after them, okay? Pretty clear evidence. Go to the ocean surfaces. Doesn't matter where you go, if you just look between 0 and 30 north latitude, look at that increase right there. This is 1880, there's current time, that's an increase. Look at it here between the northern and the southern areas around the equator, there it is. There it is down and just below the equator there, okay? So, the sea surface is warming. Now, the CO2 in the atmosphere increases temperature. That temperature, 90% of it, gets absorbed by the oceans. And the oceans are hence warming and actually slowing down the warming on land because they're absorbing much more of it. The oceans are also absorbing the CO2, and that's making them more acidic. They're not acidic. You know, pH, it's dropping, but they're not in the acid range, but it's dropping. It's about 8.1 now, okay? So if we look at the heat content of the oceans, the last 10 years, I'm looking at the red's for the area of 200 meters, from 0 to 200 meters, the shallower waters in the ocean. The last 10 years are the warmest 10 years on record for the ocean heat content. This is not surface, this is the ocean heat content, okay? This is the colder water is increasing in temperature. I mean, the lower depths are increasing also, but not at the same rate. There's a scientific consensus. This is my slide for consensus. Those are American associations, science associations. We have an international one, the Intergovernmental Panel on Climate Change. I left off all the other associations all around the world and all of their national academies of sciences, etc. But they all could be on this slide. I don't have time to cover them. Conclusions. The Earth is warming. There is a consensus. The causes increased greenhouse gas emissions. There's a consensus. And those are anthropogenic greenhouse gas emissions, the emissions that humans are putting into the atmosphere through the burning of fossil fuels. And the solution involves reduction in greenhouse gas emissions. Pretty straightforward science. Are there any impacts? Should we do anything about it? Because if there aren't any impacts, then who cares, right? We don't have to do anything. Well, there are a few impacts. Droughts and heat waves. Cascades and feedbacks. Freshwater scarcity leads to agricultural disruption, food scarcity, health problems increase, climate refugees. Refugees are a big impact from climate change. Social and economic disruption, geopolitical conflicts. This first cascade could describe the Syrian war. It started with a major drought, all right? And all of those cascading effects can be seen from that war. Let's do another cascade. Increased number and intensity of wildfires, again, coming from the droughts and heat waves. Leads to habitat destruction, species loss because of the habitat destruction. Increased greenhouse gas emissions because of the burning of all those fossil fuels, the trees. Decreased biosequestration of CO2. The trees aren't there any longer to take the CO2 out, which they do via photosynthesis. So they're not sequestering it. Increased warming, that's a feedback. And it's these feedbacks that are really a problem because it's not just what we put in. Now we've generated a feedback and the warming continues to go. Okay? And this is one you're all very much aware of because in your own area, Northern California, we have had increased number and intensity of the wildfires in the recent years. Okay? I didn't put, you could also describe from this cascade, take some arrows off of it. The human impacts, the loss, the economic loss, the lives lost. So you can expand these any way you like, and you can be very creative in doing so. This is Australia. You all know what's been going on in Australia. More impacts from global warming. Shrinking Arctic and Antarctic ice sheets, melting glaciers, melting of Greenland ice sheet, ocean warming, rise in sea level, ocean acidification. We've already talked about ocean warming a little bit, how it warms, and ocean acidification. We haven't talked about impacts, so those will come up. Here's the Arctic ice cover is receding. Again, as that occurs, more water is entering the oceans because the ice is melting, giving rise to some rise in the level of the oceans, okay? It also is cutting down on the reflection that reflective capacity ice has to reflect the heat back into the atmosphere. So it's being absorbed by the water, the darker waters, as opposed to being reflected back, so there's an increased warming from that. So not only do you get the sea level rise, you also get some increase in warming. This is recent. This is just a few days ago. You might have seen this in the press. 18.3 degrees centigrade in Antarctica. That's 65 degrees Fahrenheit in Antarctica. And a couple days later, it was 69 degrees. I don't have a slide of that one. It comes too rapidly. Decline in the Greenland ice sheet. If you go to the 1990s, the Greenland ice sheet was releasing about 25 billion tons of water through melting. If you come to current times here, it's releasing 234 billion tons per year. All right? That's a huge increase in the rate at which this ice is melting. And you can see it there. That ice sheet holds enough water that if it completely melted, it would raise the ocean 7.4 meters. Okay, sea level rise. We're right here, we're right there, I mean. We're not getting much. About 8 inches of sea level rise right now. And these lines just say, well, if we don't do anything, if we keep burning fossil fuels and the population keeps growing, it's going to get way up here to 2.5 meters. All right? But it could be as low as less than half a meter. Okay? So it all depends on what we do. And that's all I want to show on that slide, is that it depends on what we do. Sea level rise, larger storm surges, increased flooding, social and economic disruption, land destroyed, et cetera, et cetera. Another warming loop here. Okay? Warmer ocean, increased number and intensity of hurricanes, increased flooding and property damage, social and economic disruption, food and fresh water scarcity, increased health problems. We've seen these. All of these impacts that I'm talking about are occurring now. I'm not talking about future impacts. These are occurring now. Houston. 3 500-year flood events in the last 5 years. That's not random. Hurricane Harvey, $115 billion in damage. Venice. Now, Venice has had flooding problems for a while. They're just being exacerbated now. This is a very recent slide from Venice. You probably saw it. If you go to 2019, just last year, and you look for billion-dollar weather and climate disasters, in that 1 year, in this one country, there were 14 of them. Okay? That's about twice what they used to be. Cascades and feedbacks. Snow and ice melts in the Arctic. It exposes Arctic permafrost. Permafrost absorbs heat. Thawed land releases stored CO2 and methane. The permafrost, it's permanently frozen, is now starting to warm and melt. And what's in there? CO2 and methane. Methane, under certain circumstances, can be 80% more potent than CO2 in terms of heat trapping ability. So although it only accounted for 16% of the atmospheric gases, it can have a major impact. All right? And that is a very nice loop, feedback loop. Increased ocean temperatures. As the oceans warm, the coral reefs have a problem. This is a beautiful coral reef. This is a coral reef that's undergone bleaching. Okay? Now, the coral reefs are the tropical rainforests of the ocean. So when we lose coral reefs, we lose the equivalent in the ocean of the tropical rainforests. That's a major ecosystem loss. And this is already occurring. Future impacts. Now, what's going to happen in the future if we don't, from global warming? Because we haven't warmed, but a little less than 1 degree centigrade up until now. So all that you're seeing is coming from a little less than 1 degree centigrade. Island nations are lost. The Marshall Islands, the Maldives in the Indian Ocean, etc. They're going to be lost. Ocean warming is, the rising oceans are going to just inundate these low-lying islands. Vulnerable cities will collapse. What's a vulnerable city? New York, population 8 million. Miami, Jakarta, Indonesia, 10 million. Norfolk, Virginia, the largest naval base in the world is in Norfolk, Virginia. And they're rebuilding their docks. They're raising them. What a collapse of cities, what's that going to lead to? Refugees, right? Climate refugees, hundreds of millions. Not the million that we saw from Syria, but hundreds of millions of refugees. One estimate takes it up to 1 billion. But I think that's stretching it a bit. Hundreds of millions is not stretching it a bit. That's a lot of refugees to the world accommodate. We're having a hard time accommodating the million from Syria. The island nation of Kiribati is already losing its island. More impacts at 2 degrees. Increased rate of species extinction. A new paper just came out in Proceedings of the National Academy of Sciences about a week ago. Says by 2070, they expect we'll lose somewhere between 16% and 30% of species on the planet. All right? We all know we're living in the 6th great extinction period. This is just going to accentuate that. Now, why is it 16 to 30? It depends on what we do. It doesn't have to happen. If we do nothing, they say it's going to be 50%. So they're being kind. Coral reefs are lost. At 2 degrees, they're lost. All right? We haven't lost them all now because we're just under 1. Increased number of extreme events. Extreme heat waves, you're going to have cities along the equatorial band that just will not be habitable any longer. More refugees. Economic loss is now in the trillions of dollars per year. Not billions anymore, but trillions of dollars per year. Some estimates are like $15 trillion a year. Okay, we need solutions, right? Let's talk about solutions. There's a problem. What's your target? What do you want? What do you guys want? You're the young ones, you know? You probably want a habitable planet for human life and civilization. That's all you're asking, not a lot, okay? So that's a target. What is a habitable planet for human civilization as you would like it to be? Well, you need to develop global solutions designed to attain that target before there are massive disruptions to the global environment. Because some of these things, once they get started, aren't going to stop. When the CO2 gets in the atmosphere, it's there for decades. All right? So you're already talking about time lag. The Paris Accord gives you some idea of what might be a habitable planet for human civilizations. It was a historic universal agreement. You think about every country in the world getting together and talking about this stuff and coming up with an agreement. Limited temperature increase to less than 2 degrees centigrade. That was their goal. Get it below 2 degrees. Hope to get it down to maybe 1.7, 1.8. Okay? Non-binding goals were set by each nation. So they make pledges of what they're going to do to try and get to that target. 197 countries signed that agreement. It's a global diplomatic success. It's a success, why? Because if we do nothing, this is if countries do not act at all, we get to 4 to 5 degrees centigrade. You already saw what occurs at 2. You don't want to even try to imagine what occurs up there. Okay? So that's not what you guys want. All right? I'm old. But I don't want that for my grandchildren or great-grandchildren. So here's one plan. If you follow current policies, we'll get to about 3 degrees centigrade. Okay? If we follow the pledges, we're going to get to about 2.5 or so. Okay? So the Paris Accord doesn't get us there. The Intergovernmental Panel on Climate Change reported in 2018, we really should have a new target of 1.5 because 2 isn't that good. Why? Because there are 10 million fewer people at risk from sea level rise if we can do 1.5. Population exposed to water stress is reduced by 50%. Avoid loss of 1.5 million tons of marine fisheries. I haven't even talked about the economic losses to specific economies. Significant decrease in permafrost thawing. We'll have less permafrost thawing. Better chance to avoid climbing tipping elements. Here are the tipping elements. It just means, because we've talked about these, that some of these, once you get them started, you can't stop them once they get past the tipping point. And that ice sheet's going to go completely in Greenland. We don't know what the tipping point is. You know, we probably don't want to find out. Okay? We already know about coral reefs. These things are happening now. We probably aren't to the tipping points, but some people think we've already passed them. So I'm trying to be a positive person, not a negative. So we really need to change what we're looking for. So that's out. That's really out. That's kind of out. We want to get more to the 2 degrees, but really we want to try and get down here. So here's the current feeling. You've probably been hearing about this. We have to do a lot now by 2030. So we really have to have a 45% decrease in greenhouse gas emissions worldwide by 2030 to be on a trajectory to get to 1.5. Now that's a huge undertaking. If we don't get there, well, we'll still be on a trajectory, so don't give up. Keep working towards something. But it's going to really take some real action. And if you get to 45% decrease from the 2010 levels, is what they're talking about here, then somewhere around 2050, 2060, we will get to 0 net CO2 emissions. What we put in, we're taking out through whatever actions occur. I haven't mentioned that all of these scenarios put into there, we're going to have some technology that's going to remove CO2 as well as the biosequestration. We don't have that yet, okay? But we'll get some carbon capture on plants. I think that's something real that we can do, and I have to keep moving. Okay. Okay. Sources of greenhouse gas emissions, where they come from, the United States, transportation, electricity industry. So we want to target those areas to drop our greenhouse gas emissions. Solutions: replace, reduce, remove. Take a coal-fired power plant and change it to a solar-fired power plant. In sunny areas, it's cheaper. So that's going to happen, all right? Then you have wind power, et cetera. That's what replace means. Reduce, conserve. Don't drive as far. Don't drive as much. Drive a vehicle that gets good gas mileage. Drive an electric vehicle. By 2040, the majority of vehicles will be electric. So things are moving in that direction. Remove CO2 from the atmosphere. Stop putting it in and remove it. Got to develop the technology there, or plant 1 trillion trees. And that is a proposal, and just about everybody's in favor of that one. There's a problem. There's a time lag, right? You plant the tree, you got a couple decades before it's going to be sequestering much. But you got to start somewhere, so do it now. Don't talk about it for another 10 years like they talked about this since the 1980s. Do it now. Okay, so what can you do? Diet. I'm not talking much about diet. There's good information present. The agricultural department and lots of different places can give you information about that. But we all understand that if you have a diet based on plant proteins, primarily plant proteins, you have a much smaller carbon footprint than if you have a diet based on primarily animal proteins. So we have to change that somehow or other, because there is a lot of CO2 coming out of the agricultural sector and land use sector. Okay? Reduce use of fossil fuels. You know that plant trees. Here's a good one. Adjust your financial decisions. Jeff Bezos just agreed to put $10 million into climate change. $10 billion. He adjusted a financial decision. Now, you probably can't make that adjustment. But you can certainly join a climate change organization that will force other groups to make those kinds of adjustments. Because we've now adjusted over $11 trillion in divesting from portfolios. Divested fossil fuel industries from portfolios, $11 trillion. These portfolios are no longer investing in it. That puts pressure, right? And BlackRock, the largest asset manager in the world, has $7.4 trillion in its portfolio, has now agreed to divest from fossil fuel industries. Okay? That's a big change. So you join an organization like this, and you do a lot. You can do a few things of your own. You should, all right? But primarily, you have to get involved to put the pressure on the policymakers, because they're the only ones who can solve this. Food, I just want to point out one thing on food: beer. Okay? Now, there's a lot to do. I'm not trying to make a joke of the diet. The diet is very important. Agricultural sectors are very important. But we could have a beer after this seminar. Okay? Look at the sector, transportation sector in the United States. Do you know the United States has over 20% of all the automobiles on the planet? It's huge. Something like 270 million. We only have 331 million people in the country. So we've got room here, room there, all right? Industry, iron and steel and cement, huge carbon footprints. We don't have solutions going on there yet, but this is a time to get them started because they have very large carbon footprints. How do we get things started? Policy should have a large and meaningful impact on greenhouse gas emissions. I've shown you target areas. Policy addresses a problem area where there are not as yet good solutions, cement and iron and steel. We need to get something going there. Policy has a good chance of being adopted. That's a big problem too. You can have policies that you know will work, but if you can't get them adopted, then they don't work. All right? Look at, I want to use this model quickly. This is for solar. But you can change the name from solar to wind, to batteries, to electric cars, to cement, to iron and steel. And you can follow this same path. You want something done? You use research and development funds coming from the government or venture capitalists to develop a technology. You want to pull carbon out of the air? Get some research and development going now, okay? Once you get the technology developed, you give it to the private sector and they scale it up. That's how you bring prices down. And then you've got the prices down to a point where someone can afford it, either an industry or an individual, and the government comes back and says, all right, we will give you a tax credit for that. And installations go up. A beautiful little graph. It worked for solar. It's working for wind. It's working for batteries. It's working for electric cars. All right? It can work. It does work. And people love tax credits. Look, red means we love it. Orange means we kind of love it. Way up there, okay? So it's a policy that will pass. You could put in carbon taxes. Carbon taxes would work, but carbon taxes aren't accepted, so the policy doesn't get in place. We're still probably going to have a mixture of all these, but there are ways to do it that work. This is the energy consumption for the United States. We've got now about 11% renewables. You see it's small for solar, but pretty larger for wind, but all of these are increasing. I want to show you how it's possible. This is California. We have 31% renewable now. That's 2018. Our goal was to reach that by 2022. We're ahead of schedule. You can get it done. It's possible. All the dark green states already have performance standards set of what they want to have in terms of renewables by 2030. So they've set performance standards, the dark green. The light green have them too, but they're voluntary. And the gray are still discussing them. Okay? California, gross domestic product is increasing. We're looking at 2000 to current, or 2017. It's increasing. Greenhouse gas emissions are decreasing. Per capita are decreasing even faster. The economy is growing. Greenhouse gas emissions are going down. Don't believe the rhetoric that says you're going to destroy the economy if you do something. It hasn't happened in California. Ask why. Who's saying you're going to destroy the economy if you stop using fossil fuels? Who's saying it? Ask yourself that. Okay, I did the divest. This is from a paper in PNAS that just came out. But we've talked about all of these things to some extent. Reveal moral implications of fossil fuels. We, the industrial world, are producing the pollution, the CO2. The major effects are going to first hit the poor, the third world countries, because they have the least amount of resources to mitigate, to adapt. All right? That's a moral issue. We're the ones producing it. They're the ones who are suffering from it. That has to be worked into any solution. And let's try disclosing information on packaging. We do it for diet, right? For ingredients, the healthfulness of this product. We could do it for carbon footprint. Why not? Doesn't cost anything. Put labels on it so you know what you're buying. That could really help. Okay. And lastly, educating girls and family planning. This is Project Drawdown. They have a website with lots of solutions, but a big piece of the pie is educating girls and family planning. It doesn't require new technology. It doesn't require research and development or tax credits. It requires caring. Reduce the population size, one big part of this family planning, that reduces the problem. It makes it easier to deal with. Population is expected to get to about 9 billion by 2050. That's just going to exacerbate things. All right? Now, a memorial shield was installed on a monument on the former glacier in Iceland last August. And this is what it says. Only you know if we did it. Vote. A good friend of mine said, silence is consent. Thank you.
So Rachel will be screening, Dr. Teasdale is screening some of the questions, and we'll pass those on to Dr. Abruzzo. And thank you so much for that presentation. And maybe while she's screening, if you have any other words that you'd like to share with the group, Dr. Abruzzo.
Can you hear me? All right. Well, a couple of things I'd like to say would be, number one, I forgot to mention that the Intergovernmental Panel on Climate Change and Al Gore jointly received the Nobel Peace Prize in 2007 for their work on climate change. Also, just today, the Business Roundtable, a major trade association that has many of the largest and most influential firms in the United States as its members, will endorse a market-based mechanism to curb greenhouse gas emissions. They haven't reported what that market-based mechanism or mechanisms will be, but it is a start, and it shows that we're moving in the right direction and people are listening and making changes. And also just yesterday, ProPublica and the New York Times Magazine are involved in a joint effort to publish a series on global migration caused by climate change. This is predictive. They put it out for the world, and then just yesterday, they put it out for the United States. So you can look to find that. It's quite interesting reading. And one last thing, I have a quote here. Humankind is challenged, as it has never been challenged before, to prove its maturity and its mastery, not of nature, but of itself. That was written by Rachel Carson in 1962. If there are questions, I will answer them.
Great. Thank you so much, Michael. We really appreciate your presentation, and we'll share the chat with you later. There's lots of notes of thanks. One of the questions that has come up is that since we've known about this for so long, and scientists maybe have not done a great job at communicating the importance of climate change, is there maybe an argument that scientists need some PR expertise to help join the communication effort? What do you think about that?
Well, certainly we need better PR because we don't communicate that well with the general population. And I've been trying to deal with that my whole career. We have a special jargon that we use frequently. We don't seem to change that jargon when we're talking to non-scientists. And so they all think, or the population might think, this is too difficult to understand. So yes, we could do a better job. And I think we've been doing a much better job since the late 80s, or at least in this century, since the year 2000. But still, you're fighting an uphill battle, just like you had to fight that battle with the tobacco industry, and they have resources that we don't have.
Right. Yeah.
That's my answer.
Okay, thank you. Another question that has come up is, what do you recommend for those of us who are very concerned about climate issues? What do you recommend when friends or family, people who we don't really want to have a big argument with, a big throwdown, how do we communicate this without falling into political conversations, without turning this into a non-scientific conversation?
Okay, why don't you ask me an easy question?
Well, I saved the hardest one for second.
Okay, well, that is a very difficult question. And see, this is science, but it's been politicized. I believe that the science is solid, extremely solid, and the scientists who do the work in this area have a consensus. It's extremely solid. And I think I produced a lot of solid evidence in this video. But be that as it may, if there are people who don't wish to accept that, you have to find a way to communicate with them such that little by little, they will begin to understand how extremely important this is. Because this is extremely important. When people say this is an existential threat, that is exactly what it is. And if we don't do something, our grandchildren and great-grandchildren are not going to have much of a life. And that's extremely unfortunate. So we do have to get better at communicating and talking with our friends and relatives who may disagree. And share data. Just ask them, if with these data, what is it you have a problem with? I don't really know. I've kept trying. We're all in education. We try as best we can. But if people don't want to accept something that they have a difficult time with, for whatever reason, we have to understand why they have a difficult time with it. And that falls out of our realm. I think that's more social science or behavioral science. And so maybe we just need to work with broader groups. Next.
Great. So another person brought up our current state of the West Coast in terms of the millions of acres of burned area. and how that might be impacting or is impacting absorption of CO2 from the loss of those forests. And I wonder, or the question comes down to, is there a way to predict what the impact of these wildfires is on our overall greenhouse gas emissions?
I'm sure there is a way to predict it because we know the acreage of trees that we've lost. And there are people who could come up with that number. I don't think it'd be that difficult, but it falls down to land use. The land use was biosequestration and now it's not. It would be very similar to deforestation in the rainforests. So that can be calculated. I don't know the calculation.
Okay, great, thank you. There's another question about, could you explain how diseases will be affected with climate change?
Okay. Disease, well, as temperature rises, it puts stress on individuals. And the heat stress can cause problems with your health and well-being. But with specific diseases, it might cause a range being expanded of malaria, okay? Those kinds of things. But other than that, I think I would have to really think about this and expand it in many different areas. But I suspect, yes, there will be an increased amount of disease because of the increased heat and also the scarcity of water, the stresses on basic life-sustaining systems. Migration is going to cause disease. You won't have a home any longer. You won't have a medical community is taking care of you because you're just migrating. You're moving around the planet and you have no source of health and well-being.
Mm-hmm. And that's human disease, that the examples that you were giving, but maybe also plant and wildlife diseases as well. Would those also be impacted?
Yes, species loss.
Mm-hmm.
And that, we're already seeing that. This is the 6th great extinction period. Okay. I like to call it, well, it's the extinction period.
Yeah.
Human-induced extinction period is what I like to call it.
Okay, well, those are the questions that we have. Oh wait, there's one more late breaking question. And that addresses the state of our headway that maybe we have made on things like Western bark beetle attacks in the Western US. Is that something that has improved, or is that continuing to be exacerbated with climate change? Well,
probably exacerbated, but as the forests get healthier, that's how it gets improved. And so maybe the burning is going to bring about new, healthier forests. And so through time it may be, but that's not my area of expertise. So I'm just guessing now.
There's a note in the chat that says beetles are worse. So I think that helps. Okay, well, thank you so much, Michael, for your presentation and for taking the time to chat with us and answer some of our questions. I'd like to ask Adrian if she could come and say something quick about the museum, and then maybe give us a quick overview of what's happening next week. Adrian, do you want to unmute and do that real quick?
Sure, I just wanted to thank everybody for being here and kind of going on this little Zoom journey with us. Thanks, Marcia. Thank you so much, Professor Abruzzo, for being here. We hope you join us for the rest of the series. If you like Gateway and would like to see us continue to do more programs like this, we're really geared up to do that in the coming semester, as we will unfortunately remain closed. But we definitely want to do more of these kind of programs and work out all our technical kinks and really get this to be an important resource for the community. So thank you so much for being here, and come back next week and every Wednesday through the end of October. Thank you so much.
Thanks, Adrian. Thanks, everybody, for being here. We'll see you in the upcoming weeks for one more recorded lecture, and then the rest of the lectures will be live. So thank you again. Have a good night.
Good night.